Then what should we do? I believe we should do mathematical AI. Doesn't matter what's the name you call it. Okay. So when we look at the output, we have a trained model, right? So when you look at the input, for example, images, they are always high dimensional space. The AI trained model is also high dimensional space. So the problem becomes this: how do we understand high dimensional space? For AI students, you may know that AI has a curse called the curse of dimension. If the dimension increases, the AI algorithm doesn't work or do not work well. So AI still is not good at high dimension. There's now currently a popular solution is to reduce the dimension using CPA called component CPA. Sorry, I forget my age. I forgot what does this stand for. Anyway, so what they do is they try to reduce the dimension. For example, it was 4 dimension. I reduce it to 2 dimensions. Then we can do the calculation and so on, right? So, but this kind of reduce the dimension, does it work? Sometimes, but not always. Here I give you the reduced dimension sometimes doesn't work, right? For example, we have 3 points, A, B, C. If you put them in 1 dimension in a curve, in this black curve, you see AB is shorter than AC, right? However, if you put these 3 points in 2 dimensions, in this 2-dimensional space, so AB, AC, AB is longer than AC. That means different dimension, we have different conclusion. So if you do dimensional reduce, you may end up with a wrong conclusion, right? Another example, we know in 2D space, two parallel lines, these 2 parallel lines will never meet each other. However, on the Earth, on the equator, you have 2 parallel lines. If you extend them on the surface of the ball, then they will meet each other, right? So these 2 examples I want to, very simple, I want to give you to think about the problem of dimensional reduction. Okay. Then we look at the mathematical space to try to find the tools. About more than 100 years ago, when Albert Einstein, he tried to develop the general relativity, he cannot make it. Then someone said, you need to read the remaining geometry. Then he did. Then, he had the general relativity. So the tools, he studied is that one called differential geometry. Okay, it's a geometry of the high dimensional space. Give you a simple example. This is our Earth, right? You know the Earth, the surface is curved. However, in a small area, for example, at Ho Chi Minh City, we believe this space is flat, right? So in a small area, it is flat, but in the whole Earth, it is a curved space. Okay. So that's basically the philosophy of differential geometry. Like vector, usually we know, right? The dual vector, tens, metric, all these are the concepts in differential geometry. So you may say, oh, that's physics. You may say, well, I remember, if I remember correctly, in 2016, there's a few professors. This one Michael Bronstein and his group, they developed a new branch called geometric deep learning. They try to use differential geometry to do deep learning, right? So 2016, the paper published at the maybe IEEE system journal or somewhere. Okay. They also have a free book. The book called Differential Geometry Deep Learning, Grade, Groups, Graphs. Those concepts are quite familiar with us. But what is the geodesic gauge? That's the physics concepts, right? But you can learn it. Even a second year undergraduate student, they do it, so we can do it. Right? So how to deal with nonlinear problem? Maybe we can use group theory, right? So if you're familiar with cryptography, then you may know something about it. Okay. So once we use differential geometry to build, he is a mathematician. He said, "Oh, you computer guys, you IT guys, whatever you need theories, we developed for you already. Your task is to learn our knowledge and apply it to solve your problem." Okay.
Yes, sir.
So that's okay, great. So if you want to solve the problem, the theories are there already. Say Lie group, Lie algebra, general linear group, and so on. So all those in the second year undergraduate textbook, right? So our task is to learn them and then to bring them to solve our problem, right? If you say, you ask the people, mathematicians, they know all this knowledge, you ask them to solve those problems, they cannot, because they do not have the sense of engineering. I may give you an example, very impressive to me. Well, my friend, he is a professor in mathematics in Melbourne University. He's doing graph theory. I'm doing networking. So I say, we may collaborate. Then we can create some new good stuff, right? He said, "Oh, great." Then after half an hour discussion, he said, "Shui, your problem is too complex. Let's do this way. You go home, you write the equation for the TCP/IP protocol. You bring me the equations, then we can continue." How can I write equations for TCP/IP protocol? Right. So I realized that we are different people. So only strategy we solve the problem is we learn their knowledge and then bring the knowledge to our domain to solve our problems. Differential learning. There is some. If you search the digital library, you can find some papers there. For example, use geodesic metric on Lie group. What is geodesic? In 2D, say the distance between you and me is a straight line, right? In 2D. In 3D, still a straight line. In a 4D space, the shortest distance between you and me, you don't know. What is it? Okay, that's the geodesic. In high dimensional space, the shortest distance between two points is called geodesic. It's a physics concept. I don't want to go to the details. If you want to explore further, the mathematicians, they developed a lot of knowledge for us. A guy, he worked in Harvard, he got the Fields Award because they developed this fiber bundle. Anyway, high dimensional space mathematics. So I want to know, how can I use it? Is it useful? Right, okay. I give you some examples. This is not my work. I know this is a communication conference. Right? We use some communication concepts. For example, when we do routing, usually we think about 2D space. But now with the satellite in the sky, right? So the submarines in the water, so we should do 3D routing. Right? When you do the 3D routing, you need 3D concepts. The satellites, Professor Simon mentioned a lot. The satellites, when the satellites fly in the sky in a high speed, based on Albert Einstein, the time will shrink. When we do our research, do we include this in our research? I guess most of the time, maybe no, right? Okay, so, and the robotics, control, sensing, and so on, right? So antenna design, I saw papers in those domains, okay, using differential geometry. Can we use, one problem is when we do the face recognition, usually, traditionally, we use image, right? It is 2D. But some kids, they use the father's image to take money from the ATM machine, right? So 2D is not enough. So we need to do 3D face recognition, right? And say 3D fingerprint, deep fake detection. Right? So the AI now is very powerful. They can create a lot of fake videos. How can you know this one is a fake one or a genuine one? So we need something deeper underneath to help us to do the detection, right? Of course, not related with this. Someone said that computer AI generated people, they do not have heartbeat, right? Okay, you may use this to do the detection. Okay, you can use the geodesic for convergence optimization for AI training, right? So this, if you do not believe me, that's okay. You may know this gentleman called Michael Jordan. Maybe next year he will get the Nobel Prize in physics. I'm not sure. I hope, right? He's a big AI guy in the States. So this is his paper, okay? Published in NIPS. It's a top conference of AI, NIPS 2022. You see, Michael Jordan, Berkeley. Okay, so the first order algorithm for min-max optimization in geodesic metric space. Okay, so I give you one more reason why you see the big guys they are doing this. Okay, of course we also have some more dimension. Right, so you can increase the dimension to do classification. Okay. Of course, I prefer this. Right, so we try to do some semantic communication. Our purpose is to do semantic communication, security, and privacy. We try to use differential geometry to do the semantic extraction. Right, if there is a video, then what does that mean, right? So, for example, in our Asian people, we usually very polite. We do not like Western people, very direct. Can I borrow $1 million from you? That's the Western style, right? The Asian people may say a lot of things, at the end may say, I need $1 million, right? So that's how to extract the semantic. That's big task of AI. So anyway, we also do something. We try to combine it with the